Professor, Department of Analytical Chemistry, Sanjeevani Mahavidyalaya Chakoli. I welcome all the students of B.Sc. first year to this online lecture. Student friends, in last lecture we have learned or we have discussed about the unit first from the paper number 4, that is nothing but basic analytical chemistry, and the name of unit is the gravimetric methods of analysis first. In this we have already discussed about the different concepts, that is what is the principle of gravimetric analysis, what is gravimetry, and then what is the entire procedure for the gravimetric analysis, what are the steps which are followed in the gravimetric analysis, and so on. So in today's lecture we are going to learn about the new topic from this gravimetric methods of analysis. The name of topic is the gravimetric conversion factor, and regarding the illustration of the different ions with respect to the gravimetric conversion factor. So today we are going to learn about this topic. What is the gravimetric conversion factor? It is a very important factor which is used in the calculation of the gravimetric percentage or the amount for the given elements or ion. So let's begin with the gravimetric conversion factor. So what is the gravimetric conversion factor? So stoichiometry and gravimetric conversion factor. So what is the stoichiometry and what is the gravimetric conversion factor? So what is stoichiometry? Stoichiometry, a branch of chemistry which deals with the relationship between the reactant and the product of the chemical reaction, is called as the stoichiometry. What is the stoichiometry? It is the branch of chemistry which deals with the weight relationship between reactant and product of the chemical reaction, is called as a stoichiometry. Means what? By using stoichiometric factor we can balance the reaction, we can relate the weight and that is weight of the product and the reactant by using the stoichiometry. For the understanding the stoichiometry, suppose the analyte A ion react with, that is what suppose the analyte A plus ion react with the reagent B minus ion to form a product AB. Then see the net reaction is that A plus B gives AB, and what is the composition? It is what, 1:1%. That is 1:1 is the proportion of the reactant. So 1:1, which gives the product 1. Then the weight relationship between the reactant AB and product AB is referred as the stoichiometry of the reaction. So the stoichiometry of the reaction is that 1:1. 1:1 means what? The 1% of the one component, that is what, the 1% A plus reacts one component of A and one part of the B react to form the same proportion, that is what, the AB, that is 1:1. So this is nothing but what is stoichiometry. Stoichiometry gives the relationship between the weight of the reactant and product. So this type of the branch which deals with the study of the relationship between the weight of reactant and the product is known as the stoichiometry. The next topic is that the stoichiometry and gravimetric conversion factor. What is the relations between that? So the stoichiometry and gravimetric conversion factor relates. In general, the percentage of analyte A in a sample is calculated from the weight of analyte A present in the sample as follows. So if you want to calculate the percentage or the weight of the analyte A, then we can determine the percentage of analyte A present in the sample, which can be determined as the percentage of analyte A is equal to weight of analyte A into 100 divided by weight of sample. So one can determine the percentage of analyte A by using the formula percentage of analyte A is equal to weight of analyte A into 100 divided by weight of sample. In gravimetric analysis, the analyte A in a sample is converted to insoluble precipitate. As we know that the process of the determination of any component present in the given sample is done by means of the gravimetric method by using precipitation. So if you want to determine the analyte A, then it is get converted into the insoluble precipitate or insoluble compound having known definite formula. The insoluble precipitate compound is then dried or ignited to give a compound AB having known definite formula, and then it is weighed. Finally, from the weight of the dried or ignited compound AB, the weight of analyte is in the sample is calculated. To calculate the weight of analyte A from the weight of dried or ignited compound AB, the gravimetric conversion factor is used. So what is the use of that gravimetric conversion factor? Is that to determination of the weight of analyte A or any analyte, any component present in the given or the compound, and get it when it is get converted into the precipitate AB, and then this precipitate is dried or ignited, then it converted into AB, but we want to determine the amount of A. Then for the determination of analyte A, we use the gravimetric conversion factor for the determination of analyte A. So this is the use of that gravimetric conversion factor. Then how this gravimetric conversion factor is used. So what is the gravimetric conversion factor? The gravimetric conversion factor is defined as the number of grams of analyte present in 1 gram of dried or ignited compound. What is the gravimetric conversion factor? It is a simple relationship. What amount of that what the component which we have to determine, we want to determine is in the gram which is present in the what the precipitated compound or ignited or dried compound. So the gravimetric conversion factor is defined as the number of grams of analyte present in 1 gram of dried or ignited compound. So or we can write the another definition of this gravimetric conversion factor is the gravimetric conversion factor is defined as the ratio of atomic weight of analyte to the molecular weight of dried or ignited compound. It is also known as the gravimetric conversion factor. It is a simple ratio of the atomic weight of analyte to the molecular weight of the dried ignited compound. So for example, suppose the analyte A is converted to the insoluble precipitate. So this A is get converted into AB in the insoluble precipitate compound, or which then upon drying or ignition is converted to a compound AB, and then weight of AB is taken. Then the gravimetric conversion factor will be what? So if you want to analyze, or if you want to determine the amount of A, then for that purpose we have to first convert A into the insoluble precipitate or insoluble compound, that is nothing but the AB, and this AB is then further what the dried and ignited, and we'll get the compound AB with a constant weight. Then the weight of this AB is taken, and then gravimetric conversion factor will be what? See the gravimetric conversion factor, how this gravimetric conversion factor is calculated. So number of grams of A in grams of AB, or the ratio of atomic weights of A to the molecular weight of AB, as according to the definition. The gravimetric conversion factor is written as the A divided by AB. So whereas standard what is A and what is AB? So that is the gravimetric conversion factor is written as A divided by AB, where A stands for the atomic weight of A and AB stands for the molecular weight of AB. So multiplication of the weight of dried or ignited compound by the gravimetric conversion factor A divided by AB gives the weight of analyte A in the sample. So what the weight of analyte A is equal to weight of dried or ignited compound AB into gravimetric conversion factor. So we want to require if we want to determine the weight of analyte, then we have to require the gravimetric conversion factor, that is the ratio of the atomic weight of analyte A divided by the weights of analytic, that is what the molecular weights of the compound AB. So the weight of analyte A is equal to weight of dried or ignited compound AB into A by AB, that is nothing but gravimetric conversion factor. Finally, from the weight of analyte A, the percentage of analyte A in the sample is calculated by using the formula. The percentage of A in the sample is equal to weight of A into 100 divided by weight of sample. So this formula is used for the calculation of the weight of the analyte A in the sample. Then the percentage of the A in the sample is equal to weight of dried or ignited compound into gravimetric conversion factor, that is nothing but n bracket A by AB bracket close into 100 divided by the weight of sample. So in this way one can calculate the weight of the analyte present in a given sample. So the next topic of this chapter is the illustration of this what the gravimetric conversion factor, stoichiometric gravimetric conversion factor, and the examples of that. So first example or illustration regarding this gravimetric conversion factor, stoichiometric gravimetric conversion factor is the sulfate ion, that is nothing but SO4 minus minus. For the gravimetric estimation of SO4 minus minus, the SO4 is converted to BaSO4 precipitate by adding BaCl2 reagent. Then BaSO4 precipitate is digested, filtered, washed, and ignited and weighed as a BaSO4. So how this BaSO4 is determined? SO4 is determined by means of the using the barium chloride. So for the gravimetric estimation of SO4 minus minus, the SO4 minus minus is converted to BaSO4 precipitate by adding BaCl2. So the replacement of Cl2 is done by means of BaSO4 minus minus. Then the BaSO4 precipitate is digested, filtered, washed, ignited, and weighed as a BaSO4. Hence the gravimetric conversion factor, that is what GCF for the SO4 minus minus, is the number of grams of SO4 minus minus in 1 gram of BaSO4, or the ratio of atomic weights of SO4 minus minus to the molecular weight of the BaSO4. So therefore gravimetric conversion factor for SO4 minus minus is equal to atomic weight of SO4 divided by molecular weight of BaSO4 So one can calculate this gravimetric conversion factor by using their atomic weights and the molecular weights of the given BaSO4 and SO4 minus. As known, the atomic weight of sulfur is 32.06, oxygen is 16, barium is 137.33. For that, Cl chloride is 35.5, and for Ag that is 107.8. For Fe is equal to 55.85. For calcium is equal to 40.08. For carbon is equal to 12. For phosphorus is equal to 30, and for magnesium is equal to 24.3. By putting the value of S, that is atomic weight of sulfur, and SO4, as well as the molecular weight of the BaSO4, one can calculate the gravimetric conversion factor. The second one is the illustration with respect to the chloride ion. For the chloride, gravimetric conversion of Cl minus and then Cl is converted into AgCl by adding AgNO3. The AgCl precipitate is digested, filtered, washed, dried, and weighed. So if you want to determine the Cl minus, that is chloride ion, then first we want to convert this Cl into AgCl. For that, we add the AgNO3 and we will get the AgCl precipitate. So what is the gravimetric conversion factor for chloride? The number of grams of Cl in 1 gram of AgCl, or the ratio of atomic weights of Cl to the molecular weight of AgCl. Then therefore one can calculate the gravimetric conversion factor Cl minus is equal to atomic weight of Cl divided by molecular weight of AgCl. So in this way one can calculate the gravimetric conversion factor for the chloride. Then next one is the gravimetric conversion factor for ferric ion. For the gravimetric estimation of ferric ion, the Fe plus the ion is that converted into that is ferric hydroxide, FeOH thrice, PPT. The FeOH thrice is digested, filtered, washed, and ignited to give Fe2O3, that is ferric oxide, and weighed. So hence gravimetric conversion factor for Fe plus 3, the number of grams of Fe plus 3 ion in 1 gram of Fe2O3. The ratio of atomic weight of Fe plus 3, or molecular weight of Fe2O3, is given as what is. Therefore the gravimetric conversion factor Fe is equal to atomic weight of Fe divided by molecular weight of Fe2O3. Then next gravimetric conversion factor is about the calcium. For the gravimetric estimation of calcium, the calcium plus 2 is converted into CaC2O4 by adding the ammonium oxalate, that is NH4 twice C2O4. The calcium oxalate PPT is ignited to give the calcium oxide. Hence the gravimetric conversion factor for it is calcium is the number of grams of calcium in the grams of calcium oxide, or the ratio of atomic weights of calcium to the molecular weight of the calcium oxide. By formula we can determine the conversion factor of that calcium is equal to, therefore the gravimetric conversion factor is equal to atomic weight of calcium divided by molecular weight of calcium oxide. So in this way we can calculate the gravimetric conversion factor, that is stoichiometric gravimetric conversion factor for the sulfate ion, chloride ion, calcium ion, and ferric ion. So this is simple formula is that what the atomic weight of the respected analyte divided by the molecular weight of the respected precipitated dried compound. So in this way one can calculate, one can determine the gravimetric conversion factor, that is stoichiometric gravimetric conversion factor. If you have any queries regarding this topic, please put your question in YouTube comment box. I will try to answer all the questions. If you have not giving any response to the lecture, then it is not possible to give the answer. So please let it be interactive. Thank you. Thanks a lot. Have a nice day.